Okay, good morning, class. So today we're looking at exponential and logarithmic functions. We're looking at the last exercise dealing. We're looking at the last exercise dealing with the section of work, which is something to do with no, not this one. Logarithmic graphs and inequalities. Our favorite, no? Reading inequalities. So people will be looking at the examples 4, exercise 6, which is on page 57. Now, even this example is on page 57. Okay, so a logarithmic inequalities obey the log laws, but you can solve inequalities using graphs. So as I was saying here, you could use it using solving it using the log laws, or we can use the graphs. The graphs is going to be the easier approach of the two. Okay. So we're looking at the worked example on page 57. It's going to minimize this a bit. Okay, use the graph alongside to answer the following. For which value of x is log x base 2 less than or equal to 3? Or is log x base 2 less than or equal to minus 3? So let's look at the first one. Right, so let's look at number 1. Where is log x base 2 less than or equal to 3? So if you're looking at log x base 2, which graph is that? Log x base 2 is this one here, the one in blue. Where is that less than or equal to 3? So in other words, there is y is equal to 3. As we know, that's a y value, so it's this part of the graph they're referring to. Not so. So it's from 0 till that q value, whatever that q value is. Could it include 0? No. Why? Accepted. Could it include q? Yes. Why? Because that q is equal to 3. But what do you notice at this point? I do not have the q value. I do not have the q value. So what do? I need to solve it. I need to find it. Okay. So to solve for q, so I just say for q. I don't really have to say that either. I just say log x base 2 is equal to 3. I'm solving for x now. Okay. So what do? I put that onto the 2 and x on its own. Therefore, x is equal to 8. So the x value of that is 8. Or the coordinates of q is 8 and 3, whichever way you look at it. Okay, now I can answer the question. So in other words, it's from 0 to 8. Okay. Let's take this down. From 0 to 8. So x is greater than 0, but less than 8. As we said, could it be equal at 0? No. Why? Could it be equal at 8? Okay. Let's look at number 2. Number 2 says, where is log x base of less than or equal to negative 3? So here's negative 3. Okay. So less than or equal to, is that above this line or below the line? It has to be below. So it's this part of the graph they're referring to, not so. So in other words, x must be more than whatever this y value is here, which is 8 in this case. Let's say we didn't know it's 8. Okay, I know it's 8, but let's say we didn't know it's 8. Or it wasn't in line with this. Or you couldn't see it from there. Okay, then I would have said 4r. I say log x base half is equal to minus 3. The half of x. It goes onto there, x on its own. So I now say x is equal to a half to the negative 3. And half to the negative 3 is 8. Which confirms that. Not so. So what do I say now? X must be more than. Therefore, which implies x must be more than 8. Can it be equal at 8? Yes. Why? Because the graph is equal to negative 3 at that point. Okay. Is there any confusion there? Let's look at number 3. Question 3. Let's put it to the side, put this away. Alright, so for number 3. So number 3, they want to know where log x base 2, where log x base 2, which is this graph, is greater or equal to minus 3. Here's the minus 3 line, not so. And log x base 2, which is the graph in blue, so it's to do with this point of t here. Not so? Where is it greater than? So it must be more than this line, not so? So is that part of the graph they're referring to? So in other words, x must be more than whatever this x value at t is. Why? For it to be more than, it will cover this part of the graph. Not so? So what do we say? What do we say? We must solve for t, not so? So what I say, for t, with the coordinates of t, log x base 2 must be equal to negative 3. That goes onto the 2 and that goes on its own. So that will be 2 to the negative 3 is equal to x. So x is equal to an 8th. So t's coordinate is an 8th and negative 3. So we said it must be more than this x value. Not so? So in other words, x must be more than 1/8. Could it be equal at the y at negative at 1/8? Yes, because it is equal to negative 3 at that point. So it's going to be equal. So x has to be greater than equal to 1/8. And then lastly, for s, now we can see s is going to be 1/8. Okay, now let's say we didn't know that. Okay, again the question says, where is log x base half greater than or equal to 3? Log x base half, which is this graph now. Can you see that? Where is that greater than or equal to 3? This is the y is equal to 3 line. Not so, so it must be above that line. Okay, so it's from 0 to s. So in other words, is that part of the graph here. Not so, it's from, it comes very close to the y-axis from 0 to s. Okay, so how do we calculate s? For s, what do we do? We now say log x base a third sorry, of, look it up, see, is equal to 3. That goes on to the half and x on its own. So x is equal to a third, sorry, half cube, which is 1 over 8. So s's coordinate is 1 over 8 and 3. We didn't need to write it down. But we say it's from 0 till that point of an eighth, not so. So which implies your answer would be x is greater than 0 but less than an eighth. People, can it be equal at the 0? No. Why? It's an asymptote. Can be equal at 8? An eighth, sorry. Yes. So the answer is x is greater than 0 but less than or equal to an eighth. Any confusion, people? I think that was the last example for exponents and logs. So for homework, it's exercise 6. Exercise 6, you're going to do the odd numbers for me. 1, 3, 5. Okay, the even numbers you can do on your own time, but that part of the lesson will be recorded. The full lesson can be found in the description box.